Hi, this class is about continuous probability distributions, and this is an introductory set of slides. In this class, we're going to talk about the normal distribution basically, and really what we're doing in this chapter is understanding characteristics of the normal distribution to be able to calculate areas of this figure in order to determine probabilities. This is what we're doing. So the first part is understanding the normal distribution. And just to remind you, we can have different distributions. Here in this x-axis, we have any variable. Could be height of people, amount of a beverage drink by each people on a daily basis. Could be grade for students, could be GPA, could be scores of NFL team, could be sales, could be customer satisfaction, could be anything. Okay, so this x-axis could be anything, and f is the frequency to which some of these values occur. And we'll be focusing on the normal distribution. Okay, so this is just to tell you that we have different probability distributions for continuous variables. A continuous variable is a variable that has like a continuity, like numbers, like age 1 2 3 4 5 6 7, like kilometers, or income. These are continuous variables. Okay, and we're going to be learning about probabilities that we have certain values occurring in a given variable. Okay, this is basically what we're going to be doing in this chapter. And again, this is the normal distribution, and we're going to be asking ourselves, what's the probability? Imagine that you're a sales store, you sell clothes, and then what's the probability that I'm going to sell less than 10 clothes today, and or that I'm going to be selling between 10 and 15 clothes today in our store? This is what's the probability of selling this amount of products in your store. This could be a question for us to answer. Okay, before moving on applications, let's talk about more characteristics of the normal distribution. The normal probability distribution is one of the most popular. It is the most important for describing a variable. It's widely used in statistical inference and can be used to many variables like heights of people, test scores, rainfall amounts, scientific measurements, and so on. This is the formula for the normal probability density function. We're not going to be working on that. Our class will be more applied, and we're going to be using Excel to answer our questions. But it's important to understand that normal probability distribution is symmetric, which means if you like split this distribution in half, you have two halves of equal size, so it's symmetric for each one of the sides. Okay, this is one characteristic. Another characteristic is that we have two parameters to define the probability, to define the distribution. One parameter is the mean, and the other parameter is the standard deviation. Remember, we talked about mean and standard deviation in chapter 3. Okay, another characteristic is that the mean is at the highest point of the distribution, which is in the center. So this is the highest point. Here is where most values in the distribution is occurring. Okay. Also, other important characteristic is to understand the tails of the distribution. We refer to the left side as the lower tail or left side, and the upper tail as the right tail. So these are interchangeable terms for the tails: lower or left, upper or right. Get used to this terminology because many questions talk about them. Also, the normal probability distribution can be any numerical value. Could be negative, for example, -10 or 0, the mean 0, or the mean 20. Can be any negative, positive, or 0 value. Okay. Also, the standard deviation, how much the values vary around the mean, helps to determine the width of the curve. So large values of standard deviation results in a wider, like this distribution here. Or if you have low variability, which means low standard deviation, you have a thinner, like distribution. Okay. Also, this concept is very important. This is a figure, okay, and as a figure it has an area. Remember from high school that you learn how to compute area for a square, a rectangle, a triangle, a circle, and so on. So this is like an area like any other figure, and because it's symmetric, we have 50% of the area for one side and 50% to another. Let's take a look at one interesting applet here from chapter 6, under chapter 6 exploring statistics. Let's take a look at this one, deviations under the normal distribution. So I think that I showed you this before, right? So these are areas. So the mean plus and minus one standard deviation around the mean, we have 68% of the entire figure. So this entire figure has 100% of an area. So as we have certain values around the mean, we have certain amount of an area. Okay, this is what we are talking about. Let me see if I have another one. Standard. Let me see if I can use this one here to help illustrate this concept. Again, this entire figure is 100%. So if I move this shaded area until the middle, we have 50%. This is the 50.5 means 50%. So 50% of the figure is blue and the other 50 is white, okay? And we use this area of 50% to say that we have a probability of 50%. I can keep moving and I increase the area of the figure. Now I have 60% of the area. 0.6 means 60% of the area, okay? Which also is a probability. So the probability of having a number up to this point is 60%. And then you can keep increasing the area, and you see that you have 90% of all figure is up to this 1.335. So from whatever negative number we have up to number 1.335, I'm going to explain that later in another video, we have 90% of this figure, 90% probability. So this is how we use the normal distribution, and this concept is very important because you're going to be working with areas under the curve and they represent the probabilities. Okay, this is the empirical rule. Remember, we talked about the empirical rule in chapter 3. We have a specific video about the empirical rule. I'm going to skip that. Okay, and again, the empirical rule. And I'm going to stop here and prepare another video for part 2.